So before I start, like a little bit of me. So I'm this crazy person with Eastern European name, German last name, from Brazil, now in the US. So I am half Hungarian, half Italian from Veneto area, actually. So I spent some time visiting places in Veneto before coming here as well. And I've been in open source since before my academic career as a researcher in open source. So I started to work in open source around 2003 when I was doing my master's. So I had my master's, I went to industry, a gap, and then I came back to academia for the PhD. So I worked in industry with open source for 3.5 years, only with open source. So there was a state company in Brazil that were developing open source for all the other states in Brazil. So for the vehicle management department, for finances, for whatever. So we had this big boom of open source because open source was supposed to be the thing moving software in public endeavors in Brazil. So it was a great experience. At that time, I was developing software, leading inner sourcing opportunities, actually developing open source, and also organizing open source practitioners conference. Well, then I moved to a private company and then back to academia. And then I decided, like, why not doing some research? And the things that I found that were problematic when I was doing open source. So this is pre-GitHub era. So for those who interacted with open source before GitHub, may know what I'm talking about. It was a mess. So there was no formal process. Each project would do it differently. There were mailing lists here, SourceForge there. You're lucky when there was a SourceForge, and it's the GitHub from the 2000s, and it was well organized. So I tried to bring this to academia and say, like, okay, how can we make the process more interesting and easy for people onboarding and helping them not getting in, but also staying. And then I started to develop some stuff, and my very first research papers and conferences, people started to ask, like, but who told you that this is a problem? Like, you telling me that you had this problem doesn't say anything. It's like, okay. So I shifted what I was doing to try to find out if that was a problem. And there was not only one problem. There was like a big spectrum of problems, both from technical perspective to social perspective. And this kept me pushing more and more to the social and human aspect side of developing software in open source. So at the beginning, I was like really excited about mining and getting like to the technical side. How can we develop better things so people can get on board? And yeah, so you choose your truth, right? Like I was pushed towards a little bit of my truth at the beginning. And I've been mentoring open source students since 2012. So I have a course that I teach. I was on the 15th, 16th edition. I teach at least once a year at NAU, and I started teaching that in Brazil. And when people ask me, like, what is your contribution to open source now? It's like, it's this. So if I have 1 or 2 students that decide to do more after the course, it's a big win for everybody. And I've been researching this, specifically the onboarding and all this sustainability stuff, since 2011. So it'll be 15 years now that I started researching onboarding, sustainability, retention, and etc. So after all these years, what we come to is that there's a challenge of sustainability that started at some point, nobody knows when, and now it's a big thing. Actually, the name sustainability was not there when I started. It's a big buzzword now, but it encompasses a bunch of stuff. And it not only focuses on having people on board in the project, but also focusing on like, how is the project moving? Like how many people are staying and doing things inside of the project? How is maintainer load? Like burnout is being a big thing in open source, and maintainers are leaving, and we saw a few episodes of people leaving open source projects, and it just like got abandoned, and big infrastructures were depending on that. It's like, now what we do? We have a bug here. Nobody can fix it. So it is a big thing. And another big thing is like the developer churn is pretty common, and it's getting more common in open source for those projects who are not sustained and funded by big foundations or big companies. So just to give you an idea of like where I'm coming from with this. So this is where things got started when I started trying to find out like what are the issues with open source. So as I said, people asked me, is this a problem? And we started finding out that barriers for people getting to open source were not only technical, they were related to process, etiquette, tooling, and social aspects they were going through. And what we found out at the beginning, like 10 years ago, is that having a structured onboarding is critical. So if you see GitHub now, they even have like a lot of guidelines saying like, oh, you need to have this specific markdown, this other specific markdown. This is exactly towards addressing this, making it explicit that you have a contribution process, you have a structured way to get people in, you have specific places to look at when you want to learn about specific things in open source. So this work was where everything started. And then we started to look at other perspectives, because we started to dig into the onboarding, and we started to find that it's not only this specific set of stakeholders who is affected. There are other sets of stakeholders affected by this whole thing. And the first thing that we looked at was mentors, because some of the newcomers mentioned at the beginning, like 15 years ago, that they could not find people to help them. So I remember one of my first interviews with a person trying to onboard Apache Hadoop was that he said, if only I had someone to hold my hand. Because he was asking questions, but he didn't know if it was the right place to ask the question. He was receiving like pointers to places that he didn't know where they were. And so it's like, why they don't mentor, right? But they don't mentor because they're not supposed to mentor. So most of the people who were appropriate to mentor were core members. These core developers want to develop. They don't want to hold hands or mentor people or teach people. They just want to do their work. So some people, when asked about this, they'll say like, I can help someone for 5 hours, but in 5 hours I can fix $5. So this will pay off. I don't know if those 5 hours, if that person will pay off. So I'm giving to the project something that maybe a new person will not give me. And this is tied to the overload. Because when a project starts to rely on a core set of people, these people are expected to deliver, to keep the project sustainable. And the other thing related to that is that these people are not trained to do so. So you were talking about having someone brand new, talking to someone who is in the project for 10, 15 years, not trained to help someone. Sometimes they cannot speak the same language. There are different contexts, they have like different expectations, they have different understandings. And as instructors, as some of us are here, we know that sometimes you need to speak at a different level depending on who you're talking to. So if I'm talking to a first-year student, it's different than when I'm talking to a senior student or to a PhD student. So these people are not trained to do that. So it was eye-opening to see how these people are also struggling, because they wanted to have more people, but they didn't know how. And the third thing that came to the picture were maintainers. Some of these core members, they are key to projects because they are the ones that carry the load of a bunch of stuff on their backs. And when we talk about maintainers, it's a big question mark. What do maintainers do in open source projects? If you ask a bunch of people, they can give you different answers. And that's what we found in several different pieces of work that we did. And the scope of the work of the maintainers can be gigantic. Can go from technical to social to process to management, organizational kind of stuff. And at some point, they just like, I don't want to do anything like this anymore. I'll talk about something that we did. And when a developer that is maintaining a project finds out something that fulfills them more than this, they'll kick this out. And they'll just say like, okay, you take care of it now. Whoever is the one who is taking care of it now. Sometimes it's no one. Sometimes it's the community, but the community does not have another leader. So it will just die. And the other aspects is like the retention. Some people leave, even maintainers. So this is a work that we did in partnership with the body researchers. I tried to understand if it was possible to understand the effects, the risks, and the possibilities to predict when a developer is leaving. The answer is no, because the contexts are really different. And basically in open source, people have different rhythms. We try to map these rhythms to try to predict individual breaks in the rhythm to say like, okay, this person is likely to leave or not. But the key things, like we could not predict, but the key things that we found is that most of the core developers will stop at least once for more than 6 months throughout the lifetime of the project. And in most of the time, they will come back. So it's not that they will abandon the project. The ones that abandon will make the project die, but most of them will go completely inactive and come back. And when we ask them, it's like personal stuff, and they communicated. Some other person took their load for a while, so it was not a thing that was unexpected or something that just happened. It was planned and it was communicated, but it was not publicly available anyway. It was something that happened external to the communication means or any other public available source in the project. Well, with that, like all this research, we had the great opportunity to work with a community that was going through some of these challenges. So data table is our visualization and data analysis framework or tool that focuses on memory and processing optimization. And they were going through a big issue. Because the thing that I mentioned before happened. The developer, the core developer who was doing a lot of work there, found a job that was fulfilling his time, and he was just like leaving the project behind. And there was no one else taking care of that because it was working as a benevolent dictator kind of governance model where everything needed to go through this person, and the throughput was not enough. So as you see, they had issues, and one of the contributors of this project, luckily, was another faculty member at my university, and he came to me, he's like, can you help me doing something? It's like, of course. And we got some money to help them building a community. So building a community doesn't mean paying developers. And well, this is how we found the project. So they were struggling with a bunch of stuff because this person was leaving. So it was really hard for other people to join because there was no one with the whole knowledge of the system other than this guy. There was a big bottleneck. And the governance, as I said, it was a benevolent dictator kind of thing. So without this person guiding, it was not going anywhere. So we found out that it was necessary to change the whole thing and recreate the community. What I mean by recreate the community, it's like trying to bring different people on board, trying to get the people who were contributing before and giving them some rewards based on what they were doing. So our very first thing was we need to change the governance model. The benevolent dictator is not working because the person disappeared, the project went down. What to do? Change the governance model. We need to build a community. How do we do that? Bring in the community to bring this governance, to recreate this governance model. The second thing is that we needed capacity. How do we build capacity for a project? So this project here, it has millions of users. And as in our package, these people are developers. So what is the strategy here? Like, we need to train these people to give back. So we went out and gave workshops and paid for some people to go to these workshops, went to our conferences to bring users in and train them, like trying to create like some small groups in different countries to make them work, paid for some translation efforts for actual technical writers, and we tried to rebuild the whole thing. So first thing, as I said, workshops and talks, open community channels, and created like pathways for newcomers to join the community. And these newcomers are not new to the project. They were users of the project. They were just like not giving back. And we reshaped the governance model. We started with an idea and we brought the community to discuss that. So for the governance model, what we did is we used the issue tracker to say like, okay, we are going through this. And this person here is the other professor who was working with me, was part of this community. And since he was like kind of known in the project, he was the one delivering the message. And we got a bunch of people discussing here and through different channels and through individual messages with contributions to the governance model. So we provided an archetype of a governance model and the community built it. So the governance model was focusing on roles, decision-making process, and community building, basically. And as you can see, what I can show here is that we started with something involving the community, and 1 year later, we had a bunch of issues brought from the community about the governance model and what they wanted to change in the governance model. So it was not like a one-time kind of thing. The community was involved, and it's still an active thing, maintained and evolved by and for the community. 1 year later, we came back to the community and we asked them what they thought about the change. We focused on the main things that we wanted to improve when we proposed the new governance model. We had 18 answers. Some of the questions here we have 17 because they are all non-mandatory, which may sound small, but 2 years before this, the community, for the 24 months before that, the community had 39 different people interacting with the project. So 18 is kind of 50% of everybody who somehow interacted with the project, issues, pull requests, and whatever. And it was average and leaning a little bit towards positive. The things that we had negative here were brought back to the governance model and rediscussed with the community. Some of them were addressed. Some of them are just like, the comments are just like, oh, it didn't make a difference. So I disagree that this improved. So there was nothing you can do. Since it was anonymous, we could not come back to the people, but the ones that had like really meaningful, important kind of feedback, we brought back to the issue tracker, we discussed, and we implemented the governance model. So it is time now. We promise that after 2 years, we'll go back again. So it's time now in September to run another one to see how things are. And these are the quantitative indicators. So when I said that the project was eroding, it was not like a small claim. So this is the number of reviewers reviewing pull requests per month, right before we got this project started. So as you can see, like four months in a row, nobody reviewed pull requests. It means that 0 pull requests were reviewed. And the number of pull requests, the backlog of pull requests was increasing like crazy. This was the point where we brought back the community. We opened up the doors, and as we can see, like the backlog started to go down. It doesn't mean that we were counting from this 144. We had new pull requests coming in. It's like the influx was kind of the same, but the backlog was going down because more people were allowed to review and approve pull requests to get merged. So it helped a lot. There are other indicators. I just brought some. The number of pull requests per month also increased a little bit. The number of different people reviewing pull requests increased. And again, like it was after 2 years, so we could see that things were getting to a nice place. But what was the takeaway here? It's like everything that me and my group have learned could be applied to some extent in some specific things. And we could see that it was possible to see the impact of a new governance in a project. The community health is dynamic because they still bringing things up on what they want to change. And sustainable projects iterate. They need to readapt, they need to rediscover themselves, and they need to rebuild communities quite often. How do we see that? Because it was working before until something happened. We had to help them rediscover, and they're still bringing things up to readapt and recycle. Well, we worked on that for a specific project. Then the big question was, well, we mainly changed the governance and we brought some people in with workshops. How are the other projects working with governance? So my student Pedro is working on something really related to governance now. He started by doing this. We collected like a small sample of GitHub repos from the top 8 licenses. So we used the sampling by license just because. And we got like 1,000 projects from each of the top 8 licenses. Only 1,400 projects had a governance.md or governance.something explicitly documenting the governance model of the projects. From these 1,400, only 54 had more than 50 characters inside of the files. So since we didn't want to go and check like links, we had like almost the same number, 60 something, with links to an external governance model. And these things represent 2 things. One of them is like they have it somewhere else, and GitHub was just a mirror, or they are part of an organization or a foundation who defines the governance model for all the projects below them. So we analyzed only this 54 because I didn't want to go in depth at that point. We just want to see like what these people are doing. It was mostly like a exploratory study. And we found out that this is basically what they do. All of these projects that we found the governance model defined structure their organization in terms of roles and actors. It's like who does what? What's a maintainer? What is a contributor? Whatsoever. Almost all of them talk about decision-making processes and the core processes in the project, and all the other stuff coming into compensation scheme that just a few of them put in the governance model. What's compensation scheme? It's like, what do we do when we receive donations, for example? How do we split that? Who receives what, basically? Well, given that, it's like, let's see what they're doing there. It's like all of them are defining roles and actors. So we manually analyzed all of them, and we found out that there is a big different set of roles with different names and different activities. So we found 2 things: same roles doing a completely different set of things. So maintainers for some projects are just the ones who are core members for others, or developers for others. Or in some projects, maintainers are the board members that just oversee the organization of the project. And we found out that the opposite is also true. The same activities are conducted by people with different role names. And we confirmed something that has been in the literature for a while. So Egbal, who is a practitioner and writes like books about maintaining open source, mentioned that. We conducted like a set of 50 interviews a few years before, and we found out that the maintainer is a do-it-all. So we can see like this when they overlap here. It means that several projects had this very same stuff under the same role. So a maintainer sometimes will do a community manager job, sometimes a reviewer, advocate, and sometimes they would share some responsibilities with people from different jobs. What does it tell us? First, it tells us that there is no consensus about what is needed, and it's completely fine because projects have different levels and different ways of interacting. So I have smaller projects, they don't need like to define like whole set of roles because they will not have enough people to do whatever is there. But it shows us like to some extent, we further analyze that some projects just have the governance model explicit because it was like something that they put there, they never changed. It's static since like 10 years. And when we analyze the similarity, there are like a few of them that are 90%, 95% similar, meaning that they just put it there because they can have a checklist on what a good project must have. So we call whole drift. The main thing that we found here is like same titles with different duties and same duties with different titles. And we confirmed the thing that was called before as a maintainer paradox, that a maintainer does different kinds of stuff depending on what it gets. What called our attention here is that it's not only something that they start doing and accumulating because they're in the project. In a bunch of projects, it's documented. So you sign up for this job, you expect to do this whole thing here. So it is well known and it's documented. You be the manager, you be the technical lead, you be the one reviewing code, you be the community advocate and whatsoever. So this opened like something, we presented this work at Chase this year, and we had the chance to go to Microsoft to present to a group there, and they were pretty interested in understanding how AI is being taken into account in project governance. Like how, in terms of, is it a stakeholder, or how in terms of, do we agree or not to using AI? So we analyzed now more than 100,000 projects to try to find governance model. And just to check out, we checked for some keywords in the governance models like AI, artificial intelligence, LLMs, agents. And almost all the cases we found was just saying, contributions made by agents, by LLM, by whatever, are not accepted in the project. So there was nothing related to how an agent can be interacting with the project. And we think it's really important as of now, because we see a lot of buzz in the open source communities about like these agents coming in and just dropping pull requests, dropping issues and doing whatever without being requested. How can we set up something that make the agents something important at the level of being in the governance model of a project? Not only being like a small piece of text in a governance MD, because it doesn't make a difference, like, oh, an AI can review code or this. How can we formally do that? It's like not as formally as maybe we can talk about, but can we have some kind of access constraints here? Like if we talk about a company, I would like to have some agents to be allowed to come here and review code, but the agents need to fulfill a few attributes, and they may have access to some specific things, maybe not configuration files that may have like secrets, but maybe not like other stuff or environment files. But they should be able to check the pull request and to check this and that. But they need to fulfill some stuff. Who will define this stuff? How it will be defined? What are the agents, the kind of agents allowed here? Where do they need to come through to get to do what they have to do? What are the specific roles that they can play in my project? So Linux Foundation, for example, is running some experience with Anthropic to have their AI agent to help them reviewing code for some bug reports. And how are they doing that? So it's replacing one of the 3 people that they required before to review code. So it's an AI agent, but the other 2 reviewers will come after that. It means that they still need to have like the 3 thumbs up, but one of them can be the agent that they chose, not any agent. In their case, they chose because they are running this experiment with Anthropic, but what about these ones in the wild? How do we know like if the agent is welcome or not to come here and drop some piece of code as a pull request to fix an issue? Can any agent do that? Theoretically, it's open source, whatever, right? But communities are not happy about that because they're receiving a bunch of code that is sometimes like unwelcome, not discussed. They're fixing bugs that the agents found, and maybe it's not a bug, receiving code to implement new features that someone just dropped in the agent, say like, I want this new feature here, boom. So how to clearly state that? How can we create some model to make agents part of the project as stakeholders? Is it possible to do that or not? So we are starting to move into that direction because more and more it's getting a problem both in open source and in industry. They don't know what agents can and cannot do. And maybe, as I said, like it's different depending on the project and depending on the job. This guy that we talked about in Microsoft, he said like in some projects, at some moments, if it's going, for example, to the development server, we want the AI to do some stuff, but I don't want this thing to go straight to the to production. We want the AI to help us looking for bugs, but it needs to go through something. I need to choose which AI agent I'm using here. So this is kind of guiding us towards what can we do to help these communities and these software teams to onboard AI agents to their projects. Yeah, and then it opens like a whole set of cans of worms in terms of like what we can do with AI. And we've been interacting with some communities, with some organizations to try to understand what we can do. So there are 4 main threads that we are working on right now. It's like scaling mentoring with AI. This has been running since 2024 with Mozilla, basically. How to unload maintainers. This is kind of related. Better support maintainers, and how to help people with data analytics in projects. So first thing, LLMs to scale mentoring. As I discussed, like there is a bottleneck in mentoring. So sometimes like newcomers' questions will get to the project and will get stuck there for days, weeks, or months, and nobody will answer that. And sometimes it's just because like there is no effective people available to answer those questions. They're usually easy enough to be answered with anyone with basic knowledge about the project. And maintainers are overloaded, and newcomers, when they want to join, they want the help, because if it takes like 2-3 weeks, they'll just give up. And documentation, as we know, in open source is not only scattered, but it's when it's available, it's dated, or it's full of blank spaces. What we started to do, of course, we started to doing a basic RAG just to help these people. And Mozilla has this program that they onboard a bunch of newcomers in events, and they open a channel on their matrix server for the newcomers to interact, and the maintainers like face a huge overload for like 2-3 weeks of the very same question being answered multiple times. It's like, what about we try that with the messages that we have from last year? So that's what we did. We put all the documentation from Firefox in a rack, all the code, all the wikis. It took us like a whole lot of money because we use OpenAI to embed this stuff, and a long time, I think it was like more than a week, to create all the embeddings, all the vectors and everything. This was like a huge documentation, a huge set of the source code files, but it paid off. So we asked the Mozilla engineers, so we got 6 Mozilla Firefox engineers that work for Mozilla to analyze the answers that were received when the question was answered in the matrix server. The answer generated by LLM, OpenAI, I think it was 4.0 at that time, and 4.0, and then a RAG that we built. They were asked if each of the answers were helpful, comprehensive, and concise, with clear definitions of what is helpful, what is concise, and what's comprehensive. And for each of the questions, they had to pick one. It's like, what is the most helpful, the most concise, and the most comprehensive? And they had a single question at the end. It's like, if you had to choose to use one of these in practice, which one would you choose? So this helped us understand that if we fine-tune the RAG well, it will give us like nice answer for things that are backed in documentation and source code. This also helped us show in Mozilla that the problems that we found with LLM and basically with RAG were gaps in the documentation. So we got all the logs to see like when they said like, oh, this doesn't make sense. This answer is like, it's wrong, it's completely wrong. We went back to the documentation, to the log of the RAG to see like, where did they get the answers from? And the answers came from places that are nonsense, meaning that there is no answer to that specific question anywhere in the documentation. So what we are doing now is we are using this to try to answer whatever question comes in, but on the back end. So the maintainers, like the Mozilla engineers, can take a look and see like, okay, this is good, this is bad. When they're bad, we give them the log and they will revisit the documentation. So the idea is, if the answer is good, so we are at the moment of trying to find the threshold of like how to find it good or not. It will go to the newcomer. If the answer is bad, it will trigger something to the documentation teams, like you need to find out like where to add this, and then we'll create a feedback loop, refeeding our RAG so we can improve our answers on the go. And well, another thing that we found that was not related to documentation was that there was a gap between intent and syntax. As I said, we included documentation, code, and wiki on the RAG. When the answer was embedded on the code, it had a big problem. Because finding the intent of a specific piece of code is not straightforward when it's in the same embedding as we have all the documentation. They're in different kinds of level when we think about natural language. If we just have code, it's one thing. If we just have documentation, it's another. When you mix and merge, it becomes problematic to find an answer to a question here. So for example, if we find like which files changed in this bug fix, it may be easy because I'll find like the names of the files. When there is a question like where is authentication handled, it may or may not be easy, depending on what we can extract from here, for example. Authentication middleware. If it's in the same embedding, if the same RAG has all this stuff from the documentation, it may or may not find that. Because when it creates, like when it breaks this and tries to compare the vectors with this embedding here, maybe these will not come as the top, one of the top ones. So what we are doing now, we are taking one further step, and we are representing the code in natural language before we move into embedding. So we get the source code, we create an explanation of the source code, and that explanation is the thing that we will embed and put in our vector database. And we'll have an explicit link outside to say, like, this belongs to this file. And we're doing that in some cases in file level, function level, or the finer grained level as possible. So the first preliminary thing that we've done is we did not treat anything. We just dumped the source code files with whatever documentation we had. The second, we used stuff algorithm that we pass the full file to one LLM. It generates a description for the file, and we embed the description in the LLM. And the third one, we use the classic MapReduce. We summarize the chunks, and then we merge them into a single file summary. And this is the thing that we upload and we embed using the LLM. Well, I said this is like a initial preliminary thing. It takes like a whole time because we need to process like the whole source code base, and we wanted to see if it was worth it or not. So now we have a student working full-time on this because we saw that MapReduce may increase a lot the retrieval of good things from the source code. So it is easier to translate intent to whatever is in the source code if we have a textual representation of the source code in natural language as well. And these, like, we are putting back in the previous RAG to see if we can help newcomers to find things in source code files as well. And the next thing that we're doing is we're helping maintainers. So this is more like a educational tool. So as I said, I've been teaching open source for a while. So since last year, we are running this conversational agent for to help students in classroom. So half of my course is you have to contribute to an open source project. In the first edition that I did this, it's like you have to contribute to this project here. And we created the conversational agent with the RAG, and it was a shame people did not use it for different reasons. So they wanted to learn, I wanted to have the full experience, and etc. The second year, they used it a lot. I don't know if it was like I don't know if this thing will help me or not. I don't know if they are. I'm a subject to an experiment of this crazy guy, and they were. But in the second year, it was amazing. So whenever they had to find out, like, oh, how do I compile my code? They would go to the LLM and to the conversational agent. And the goal here was just to have a conversational way to interact with the documentation. Nothing other than that. It was just a RAG with a conversational agent on top of RAG. So it's just like whenever they had a question, they didn't go to the documentation. They just go to the conversational agent. And from the perspective of the community, it helped a lot because the dumb questions were not going to the community. And the last thing that we are doing, this is just a mock made by an LLM, but what we are doing is we are trying to create a thing, like a dashboard to signal community health over time. But I don't want to do something that is, oh, yet another dashboard. So our idea is to have all the sources that are available for open source or for software projects embedded into different kinds of repositories available for agents. And the agents, given the questions, they can use, like, for example, the chaos metrics. They can use the history of the project. They can use history of conversations to try to find out the information that is needed and create a customized ad hoc kind of dashboard for the maintainers. So what we foresee is to have an agent, but this agent is not a traditional agent. it's an agent that maintainers can go there. It's like, why is my project like, why is the number of pull requests increasing in my project? And you go to all these databases, to all these different sources, check what metrics are useful for that. Where do I find the information to run the metrics? What kinds of graphics can be interesting for that? So you'll have like different knowledge sources, and it will create ephemeral dashboard that the maintainer can use for that specific thing. So it's just like a quick example. I want to analyze contributor engagement of the last 6 months. Are we retaining contributors? And is too much work concentrated among few maintainers? So what it will bring back will be something like this, with graphics, numbers, and insights, depending on what they want. It's like if they don't want graphics, they just come back like, but what does graphic number 1 there represent? And it will give like textual information. So it's like a dashboard created to their needs. This is on the works now. We had a very first iteration with one maintainer on this, just for specific things, and it's not going well. But we could find out specific pieces of information that were helpful. The main concern that we found, like the main issue, was that the information required to run the graphics that the person wanted were not available in any of our data sources. So we are trying to get more data sources and seeing that if we have different agents knowing specific things about each of the sources, we would have like a better luck. But this is something real. This is something that we generated with the agent just by asking a question about the project. So the idea here is we can have a dashboard that is not something that past work did. It's just like, I have this set of projects who are facing this problem. I'll provide the dashboard. So when we talk about dashboard to open source maintainers, they will go like, please don't. I don't want more of that. But when I say like, if I give you something that answers your questions, they are more open to that. So what we are doing now, next month, Pedro is going to an open source conference with a prototype. He will give a talk, and we'll talk to developers there, to maintainers there, to try to find out. And we want to avoid the thing that current dashboards have. It's like we have pieces of information in different graphics in different places that maintainers would have to go through and try to find out how these things are connected at the end. How can we make sense of this? So we want to provide a single view relating all these things into in a single visualization thing. And for this, we think that these models can help a lot, as we could find that in other work like the RAG, we can correlate stuff from different sources into singular answers. So we want to come up with an integrated analysis for this work that is powered by foundation models, all in natural language. So there is no predefined dashboard. The dashboards will be constructed in real time, that is explainable. So they can ask like, what's going on with this graphic? Why are these graphics doing this or that? That's actionable, showing like, okay, if you keep doing this, there's a chance that the project will die. Or it seems that you have an explosion of new pull requests coming from unexplained places. You need more reviewers. And it'll bring like some analyst grade insights. Because when you're talking to people from big projects or big foundations like Apache and Linux Foundation, what they brought was that whenever we have this, that we want to analyze the whole picture, we have a data analyst in our team that will explore the whole thing and will tell us what to do. So we want to provide this analyst grade insights by bringing together things from different sources into a single visualization tool. Well, to wrap up what we've done so far, so we mapped that there are a bunch of problems faced by different stakeholders in different levels of newcomers, maintainers, and mentors. And regardless of who is facing the problems, where the problem is coming from, we could find out that sustainability is a human issue. Rarely it is a technical issue. There is a technical thing related to that, but it's usually the root cause is a human work. We tested whatever we've learned, like in 10 years, in one project, reshaping a community and building something different, trying to rebuild the community, and we could find out that the numbers moved. And we are trying to bring AI carefully as something that helps, not something that replaces. And this is a working process. Our goal is to work with AI as something that multiplies and helps sustain the project, to mentor, triage, and analyze the data that is, for now, not understandable for humans. But that's it. Thank you very much. Grazie mille.